Today, we are going to talk about something more amazing than usual. Wait, what? We always talk about amazing stuffs, but it might seem a little unbelievable, but it's science. So let's face it! Today's concern is about something opposite of simple matter. You might have already guessed by that clue. We are going to talk about antimatter. As we already said that it is about opposite of matter, simply antimatters are the subatomic particles that have properties opposite to the normal subatomic particles. Modern physics says that antimatter is matter that is composed of the antiparticles of the corresponding particles of ordinary matter. Hunt for this amazingly creepy thing began in 1928 with a world-changing scientific paper by Paul Dirac. Dirac realized that his related version of the Schrödinger wave equation for electrons predicted the possibility of anti-electrons. Antimatter is really a complex term since most of the universe consists of normal matters, and only a tiny fraction consists of antimatter. With that being known, we can guess that it is very rare. When you see antimatter being used in science fiction movies, it's usually some weird glowing gas giving some radiation out of it. But don't get fooled that easily! Antimatter looks just like regular matters. For example, antimatter would still be H2O and would have the same properties of water when reacting with other antimatter. Even some scientists may get confused with normal matter for antimatter. And no offense, but we won't even have a single clue. You might be wondering where is it found and why not let's start mining for them? Good point, but usually antimatter is found in the area with the weakest magnetic field, much like marble rolling or on the bottom of a bowl. Earth's magnetic field can also act as a sort of antimatter trap. No kidding, but antiprotons have been found in zones called Van Allen radiation belts. Don't worry about Van Allen radiation belt, we will bring you an episode about that too. But for now, let's go on with the topic. Antimatter may also exist in relatively large amounts in faraway galaxies due to cosmic inflation in the primordial time of the universe. When antimatter meets matter, they immediately annihilate into energy. What makes antimatter unique is that antimatter comes in contact with its regular matter counterpart. They mutually destroy each other and all of their masses is converted to energy. To say commonly, boom! It explodes unexpectedly. Let's go into the uses of antimatter. Antimatter reactions that have practical applications in medical imaging, such as positron emission tomography, PET for short. Antimatter have also been shown within laboratory experiments to have the potential to treat certain cancers, in a similar method currently used for ion therapy. Isolated and stored antimatter could be used as a fuel for a far space travel. This means, through antimatter we could travel around the whole universe. But the bad thing is that it is far more energetic than any of our advanced technology could handle it. Antimatter is most proposed to be used as a most destructive weapon. Antimatter has been considered as king for nuclear weapons. A major obstacle is the difficulty of producing antimatter in large enough quantities, and there is no evidence that it will ever be feasible. However, the US Air Force funded studies of the physical antimatter in the Cold War and began considering its possible use in weapons, not just as trigger but as the explosive itself. But now we cannot contain it. So right now, it is only useful to expand scientific knowledge. A gram of antimatter could produce an explosion the size of a small country. If we could contain it, it is the most energy-dense substance in the world. And with your price reduction, one of the cheapest. Okay now, but what about its value? It's pretty amazing. One antiproton reacting with one proton from the environment will release 0.3 nanojoules. This means 186.4 trillion joules per gram of antimatter. A gallon of gas contains 120 million joules of energy. 1 gram of antimatter contains the same amount of energy as 1.5 million gallons of gasoline. Think about it as a totally clean energy source for $4 a gallon. Maybe we don't power our cars with it, but definitely airplanes, rockets, and weapons. These are some hypothetical uses of antimatter in the world. Let's talk more on the hypothetical use of antimatter in nuclear weapons. If you have a modern-day nuclear weapon detonated, you will find a fissionable material within the nuke arrange the atoms and elements. Unstable, then release the energy in an explosion as you have seen in movies. However, this reaction only takes 1 to 2% of nuclear materials from matter to energy to give you the huge explosion with a blast radius of 20 km at best. Remember that this is only 1 to 2% matter to energy output from the reaction inside the nuclear weapon as it transmutes to nuclear power. The problem lies in the efficiency and cost of antimatter production and storage. Making 1 gram of antimatter would require approximately 25 million billion kilowatt hours of energy. And cost over 60 trillion and whole world economies of about 80 trillions. Now, if you were to have the exact same amount of nuclear materials to antimatter within the same type of weapon, the reaction and energy output will be what we call a total annihilation reaction, where 100% of matter is converted to energy, giving a much larger energy output. Best description is to say that it is up to 98% more effective, more explosive than the best nuke we have today. On the other hand, antimatter is extremely rare and extremely difficult to create in any quantity great enough to be of concern. So all we can do now is just imagine and make theories. Let's now talk more on antimatter around the universe and jump into some facts. Before 1928, when anti-electrons were predicted on theoretical grounds by Paul Dirac, the existence of antimatter was unsuspected. In 1932, anti-electrons were found in cosmic ray debris by Carl Anderson. The first antiprotons were deliberately created in 1955 at Berkeley Labs Bevatron, the highest energy particle accelerator of its day. At first, physicists saw no reason why antimatter and matter shouldn't behave symmetrically, that is, obey the law of physics in the same way. According to theory, the Big Bang should have created matter and antimatter in equal amounts. When matter and antimatter meet, they annihilate, leaving nothing behind but energy. So, in principle, none of us should exist. But we do. And as far as physicists can tell, it's only because in the end, there was one extra matter particle for every billion matter-antimatter pairs. The antimatter that should have prevented us from existing might still be lurking in space. Scientists are trying to solve the antimatter-matter asymmetry problem by looking for antimatter left over from the Big Bang. The alpha magnetic spectrometer is a particle detector. that sits atop the International Space Station searching for these particles. AMS contains magnetic fields that bend the path of cosmic particles to separate matter from antimatter. Its detectors identify the particles as they pass through. Our bodies also contain potassium-40 or antimatter, which means positrons are being emitted from you too. Whoa, isn't that amazing? Capturing antimatter has been a tiring and hard time since they easily annihilate. But atoms of antimatter have been trapped and stored for the first time by the Alpha Collaboration, an international team of scientists working at CERN, the European Organization for Nuclear Research near Geneva, Switzerland, after a long time. Alpha stored atoms of antihydrogen. Large quantities of antihydrogen atoms were first made at CERN 8 years ago by 2 other teams. Although they made antimatter, they couldn't store it because they instantly annihilated. That's a lot of antimatter for just one episode. Antimatter is a very interesting substance. It is even capable of curing cancer if used the right way, but it can even destroy the world if used the wrong way. And what about world economy if there was possibility of existence of antimatter in large amount? Whoa, just an idea. Maybe that will be a video for another time. Stay tuned in!